So we start with question number 1. I've opened this question on my phone. I'm not projecting it here on the PC. I hope you all have this paper last year's paper. Okay. So the first question says, for each of the following power series, find the second derivative and then shift the index of the second derivative so that the power under the summation sign is x power m. So question 1a. So we are given y is equal to the summation as m moves from 1 to infinity, and we have m plus 1 divided by m squared plus 1 x to the power m minus 1. Okay, so the question says, this is part 1, right? So the question says that we need to find the second derivative such that second derivative, and then we have to shift the index of the second derivative so that the power under the summation sign is x power m. So I have to make sure this guy is just x power m, not x power m minus something or anything else. So let's first find the second derivative for this. Okay. So the first derivative, okay, so this would be y prime. This will be equal to summation. Remember that every time take the derivative, the position for m should change, right? So here you have m from m equal to 1. So this will be m equal to infinity. Here you need to drop that power, isn't it? Okay, you drop that power of m minus 1. So we're going to have m. You drop that power, we're going to have m minus 1. You dropped it, and that other m plus 1, right? Okay. While this will be x power m minus 1 minus 1, that will be m minus 2. Okay. And then divide by m squared plus 1. Okay. So that is the first derivative. And then we repeat, we take the second derivative. So this is m y prime prime. Again, as usual, the index change to m equal to 3 to infinity. Again, this power has to drop. Okay. So drop that power. So we're going to have m. So drop that power m minus 2 of m minus 1, m plus 1. This would be x to the power m minus 3, right? So don't have to worry this file. I'll send it immediately after the class, so okay, it can be checking. Okay, and then this is m squared, but you have to write as well. Okay, m squared plus 1. Now we have found the second derivative. Now the next thing is to change this index, right? We have to change this guy to the power of m just. Instead of us having x power m plus 3, we have to change that to the power of m. So what we're going to do here, we can just add negative 3 to every m, because you know that for this to be 0, I mean to be x power m, we have to add the opposite of 3, right? So we're going to add the positive 3, right? Opposite of negative 3. So we're going to do this to every m in this series. Okay. So this will be equal to summation is equal to, so y dot prime is equal to summation. So this will be m. We add 3 to every m, so plus 3. Okay, equal to 0 or equal to 3, sorry. And then also this will be m plus 3. Okay. This one also. Catherine. What's up? So this will be m plus 3 minus 2. Okay. Similarly here, you're going to have m plus 3. I'm just adding 3 to every m minus 1. And then this will be m plus 3 plus 1, right? And then divided by, okay, this will be m squared. So in place of m, will be m squared. So to m, I'm going to add 3, right? So this will be m, as usual, plus 3. And then we'll square everything. This is m squared. Okay, and then plus 1. And then this is summation x to the power m minus 3. Okay, say m plus 3 minus 3, right? So we're going to add 3 to this m. And then don't forget, we're also subtracting 3 that. Okay, so that's how you can change that, isn't it? So what does this become? So y double prime is equal to summation. So if you move this 3 to the other side of the equation here, this is just an equation you can solve. You notice that of m equal to 0 to infinity. This is m plus 3. This will be m plus 1, okay? M plus 3 minus 2, that is m plus 1. Or the other one is m plus 2. Or this one, you have m plus 4. Okay, divided by, this is just m plus 3. Don't even expand that. You can actually leave the way it is here. M plus 3 squared plus 1. And then this just be x power m. Okay, so that's where we end. Okay. Anyone with a question here? This should be x power m, not n. Okay. So that's where we end for this one. And then for part 2.
Can you scrap a little bit and see the top part? All right, thank you.
And then for part 2, we are given, okay, we are given y is equal to summation as m moves from 0 to infinity. We have m squared divided by m plus 1, and then x to the power m plus 4. So similarly, you have to first get the second derivative for this. So the first derivative as y prime. Okay, this will be equal to summation m equal to 1, right, to infinity. Here, you're going to drop this power, okay, for the first derivative. So that will be m squared, and then drop that power. You have m plus 4. Okay, subtracting 1 from the power, this will be x to the power m plus 4 minus 1, that is m plus 3. Okay, divide by m plus 1. Okay, that's for the first derivative. And then the second derivative, summation m equal to 2 to infinity. Okay, again, we drop that power. So m squared m plus 4 m plus 3 x to the power m plus 2 if you subtract 1 from the power, right? And then divide by m plus 1. Okay. And then we have found the second derivative. Now the next thing, just like before, is now to make sure that we have x power m. The only way you can do that is by subtracting 2 from this, right? Because if you subtract 2, you're going to have 2 minus 2 there, and then you're just going to remain with m alone. So I'm going to do this. I'll subtract 2 from every m, okay? So since I've shown you from how you do it from question A, the first part, this time around I'm going to show you all this, what I was writing in blue. So you're going to do the same thing, right? This is not necessary. I'm just showing you how you do this. Okay. So this time around I'm not going to show that in blue. So now this just becomes y double prime is equal to the summation. So this will be m minus 2 equal to 2, right? So this in total will be what? M equal to 4 instead. Okay. To infinity. And then here also have m minus 2, but since this m is squared, right? Remember subtracting 2 from every m. Okay. And then here also we're going to have m minus 2 plus 4. Kindly mute your mics. So m minus 2 plus 4, this is the same as what? M plus 2. So instead of me writing that, I'll just write m plus 2. Okay, if I subtract 2 from m. And then this would be m plus 3 minus 2, which just be m plus 1. Okay. And then divide by, similarly here, we're going to have m minus 2 plus 1 in the denominator. This just be m minus 1. Okay. And then this will remain just be x power m. And this was done by subtracting, okay. This was done by subtracting 2 from m. Okay. So I've indicated here. So you achieve this by subtracting 2 from m. So that's the only thing you are supposed to do there. Okay. Can we proceed? Hello?
We can proceed.
All right. So let's go to question B of the same question 1. So we're looking at question number B. So question B says, find a series solution for the following differential equations. So B has got B1 and B2 as well. So we're given the differential equation, y double prime minus xy equal to 0. Okay. So remember that if you have this form of the equations, actually you need to use what? Power series, isn't it? So we have power series solutions of differential equation. Okay. So now we are going to apply power series. Remember that y, we assume that okay, the differential equation has got this form of solution. Summation as n moves from 0 to infinity, an x to the power n, right? So the equation given is a second order differential equation. Therefore, we have to find the second derivative for this equation, this power series, isn't it? So let's first find the first derivative. So the first derivative for this y prime will be equal to summation n equal to 1, okay, to infinity. Here we drop the power n, right? So we're going to have n an x to the power n minus 1. That's the first derivative. And then the second derivative as y double prime is equal to the summation n equal to 2, okay, to infinity. Again, drop the power here, you're going to have n minus 1, x to the power n. Oh, sorry, an, I forgot an. X to the power n minus 2. So that's the second derivative. And then we get the second derivative and substitute it in our differential equation given. So remember that our differential equation given is y prime prime minus xy equal to 0. Okay. So if we substitute the information given, the y double prime, we just found it as summation as n moves from 2 to infinity, n minus 1, an x power n minus 2 minus x, what is y? Y is the summation n equal to 0 to infinity, an x power n, this is equal to 0. Okay, so now let's simplify a little bit. Okay, so let me first, before I do anything, I'll send this x inside here. Okay, first, always make sure that you do that, you simplify it first. So if there's anything outside the summation, please make sure that you send it inside before you look at other simplifications. So this summation, n equal to 2 to infinity, n minus 1, an x power n minus 2. So if I send that x inside, remember that this x is raised to power 1, and then you also have another x here. So you have the variables of this, we have the same bases, right? You have x here and x raised to power n. And you know, according to the laws of indices, the powers has to add up if you have the same bases, right? So this is x raised to power 1, the other one is x raised to power n. So the end result just be x power n plus 1. Okay, according to the laws of indices. So summation n equal to 0 to infinity. Okay, this is an x to the power n plus 1, and this is equal to 0. At this moment now, it's the time now I have to change the power of x, right? Make sure that the power of x is just raised to power n throughout, right? So this x power n minus 1 has to be changed. Also, this one x power n plus 1 has to be changed. And the same way we have just from doing here, we're going to do the same, use the same procedure, just like I've done the other two questions here. So it'll be the same procedure. So for this one, I'm going to add 2 to every n. Or for the other one, I'm going to subtract 1 from every n. Okay, so let's do that. So for this one, I said I'll add 2 to every n. So what does it become now? So if you add 2 to this guy, n plus 2 equal to 2, you notice that you're just going to have same as what? N equal to 0. Okay, so end up having n equal to 0. Okay, to infinity. This is n plus 2. Remember that we're adding 2 to every n. Okay, this becomes n plus 1 if you have to add 2 there. And then you have an plus 2. This is x to the power n minus. Here, I'm going to subtract 1 from every n. Okay, so I'll subtract 1 from every n. So this will be n minus 1 equal to 0, same as n equal to 1 to infinity. This is an minus 1. And then you have x to the power n. And this is equal to 0. Okay. Now, what's the next thing now? The next thing now is make sure that these starting points, n values are the same, right? Okay. So you're going to follow the one with the largest value of n. So this one has the largest value of n. So this will be the reference. So I have to make other series to start from n equal to 1. So this one will be our reference, isn't it? So we have to shift this guy to n equal to 1 as well. And the only way we do that is by finding some terms, right? So at the next, we're going to start at n equal to 1. So here, remember this one is starting at n equal to 0. So I'm going to substitute n equal to 0 in this series, meaning that if I put n equal to 0 here, the next one will start at n equal to 1. Okay, so that it will match with the other one here. So let's do that. Let's substitute n equal to 0 into this. So what does it become? So we're going to have 0. So we're going to substitute n equal to 0. Okay, so I'll write for n equal to 0. You're going to have what? So this is it. 0 plus 2. So this just be 2. For the first one, just be 2 times 0 plus 1. That is 1 as well. So 2 times 1 over 2. And then this is what? A0 plus 2. That is A2. X power 0 just be 1, right? So the end result just be 2A2 there if you substitute n equal to 0. So I have 2A2. Meaning that the next one now start at n equal to 1, which will match with the reference. Okay, n plus 2, n plus 1. This is n plus 2, x to the power n minus the summation n equal to 1 to infinity. This is an minus 1 x power n, and this is equal to 0. Okay, now what's next? The next thing is to do what? Is to add like terms together. So these are like this and these are like terms because they have the same summation starting from the same point and also the same coefficients, which is x power n. So I put those guys under the same summation, right? So we have 2a2 plus just a big summation, all starting from n equal to 1 to infinity. This is n plus 2, n plus 1, an plus 2 minus an minus 1 whole raised to x power mean times x power n, and this is equal to 0. Now, since this equation equal to 0, so equate everything equal to 0. So I have two terms here. This term with the constant term must be equal to 0, and this term under the summation also must equal to 0. So we say 2a2 must be equal to 0. So this tells us that a2 is equal to 0, right? So our a2 is equal to 0, right? So keep this a2 here. Similarly, what we have inside the summation here, this question is from last year's paper, question number 1. Okay, so also what is inside there must equal to 0. So n plus 2, n plus 1, an plus 2 minus an minus 1. This also must equal to 0 because everything here is equal to 0, right? Okay. All right. So when you have such, which one are you making the subject of formula? So you're going to make it subject formula, the term, the coefficient of the term with the highest starting position. So this guy is starting at n equal to 2. So an plus 2. An plus 2 is ahead of an minus 1. How do you know that? You can just substitute. Say, okay, let me say the value of n is equal to 2, right? If I put n equal to 2, you notice that this one will be a4 because the count of a2 plus 2, or this one will be what? a1. So notice that a4 is ahead and is ahead of a1. So make a2 plus 1 the subject of formula. Okay. So if you do that, you take this an minus 1 to the other side of the equation, you're going to have an plus 2 equal to an minus 1, everything divided by what? N plus 2, n plus 1. Okay, and we are considering this for the values of n starting from 1 going to infinity. Okay, from 1 going to infinity. So we're going to say for the values of n greater or equal to 1. Okay. All right, so now let us continue. So we have an. So I'll take this question here. An plus 2 equal to an minus 1 divided by n plus 2 n plus 1. So now start substituting the values of n. Remember that taking the values of n from 0, from 1 to infinite, right? Okay, so for n equal to 1, so start with n equal to 1. For n equal to 1, right? This will be a1 plus 2, which is be a3. We're going to have a3, and this is equal to a1 minus 1, this is a0. So it becomes a0. Okay, so this will be a subscript 0, divided by, okay. So if you put 1 here, we're going to have 1 plus 2, that is 3. 1 plus 1, that is 2. So we're going to have 0. I mean, sorry, 6. So our A3 is A0 over 6. Okay. Also, for n equal to 1, also n equal to 2. So continue for n equal to 2. We end up having A4. And this will be A2 minus 1, that is A1. Divided by, if we substitute 2 here, we're going to have 4. This will be 3. So 4 by 3, that is 12. So we're 12. Okay. For n equal to 3, we have what? A5. And this is equal to A2. Because of 3 minus 1, there is A2 divided by 5 plus 2, that is 7. 5 plus 1, that is 6. 7 by 6. Oh, sorry. 5. This is 3 plus 2, that's 5. 3 plus 1, that is 4. So 5 by 4, that is 20, right? So 20 here. But remember that we already found A2, right? We said A2 is equal to 0. Okay, so we can substitute that, right? So they say, but A2 is equal to 0. Okay. So we can substitute there. This gives us that F5 should also be equal to 0. Okay. We continue for n equal to 4. We can do that as well. Let's do one more. I think you're convinced the pattern, right? Okay. So for n equal to 4, yes, please.
For where we have n equal to 3, aren't we supposed to have the denominator equal to 15?
Really?
It will be 5 by 3.
4. By 4.
Oh, 5 by 4. No, I've seen it. No, I've seen it. It's okay.
All right. Okay. All right. So for n equal to 4, we are going to have A6. End up having A6. And this is equal to A3, right? Because we're going to have 8 minus 1, that is A3 divided by, that is 6 by 5, right? Isn't it? Because we're going to have 4 plus 2 and then 4 plus 1. So that's 6 by 5. And we know A3 already. So it's A3 over 30. But we found A3 already here. What did we find as A3? Okay, we found A3 to be A0 over 6. Okay, so I'll say but A3 is equal to A0 over 6. So if you substitute there, we're going to have A6, therefore, will be equal to A0 over 180. Okay, so that is our A6. So and so on and so forth, you can continue substituting. And remember now that if you are to expand that power series here, okay, if this power series you have to expand it, it gives you the coefficients, right? And the job for us using power series is actually to find those coefficients, and we've done it. We've found some of the coefficients, isn't it? So therefore, we're going to have y. Remember that y is equal to a0 plus a1 of x. Okay, so a1 x power 1 plus a2 x squared plus a3 x cubed plus a4 x fourth plus a5 x fifth plus a6 plus so on and so forth. Okay, So let's substitute those coefficients we found. So y is equal to a0. We didn't find a0, right? So a0 just be a0, because we didn't calculate it. Neither did we find a1, so we leave it the way it is. We found a2. A2 is equal to 0. So if you put 0, it can just be 0. So you can skip a2. a3, remember very well, it was a0 over 6. X power 3. a4. Okay, we found a4, did we? a1 over 12. Okay, so a1 over 12. X to the 4th. a5. a5 we found 0 as well. So can you skip it? a6 we found it. a0 over 180. X to the power 6. So the pattern goes like that. Okay, so you can either leave like this, or you can just like arrange the a0s, those terms that contain a0s, and also the terms that contain a1. Okay, you can do that. So y is equal to, I'll factorize a0 from all the terms that contain a0. So from this one, we factorize a0, we're going to have 1. From this one, factorize a0, we're going to have 1 over 6 x cubed. The other one, factorize a0 here, I'm going to have 1 over 180. X to the power 6, plus so on and so forth. And then for a1, from this one, if I factorize a1, I have x, plus the other one is 1 over 12, x to the power 4, plus so on and so forth. Okay. Are we together? Are we together, guys?
Yes.
Yes.
Okay, so let's move. We move. So I'm highlighting this, the answer. Okay, so what is the next question? Let me check. Okay. So part 2. So for part 2, we have x squared plus 1 and then we have the second derivative minus 4x, the first derivative, plus 6y.
So I have a question before you carry on.
Yes, please.
So I came across something where instead of equating it to 0, we were equating it to some variable x. So how do you treat it like that?
Okay, I think the best way is for you to bring on that question. Okay. Because I can explain, yes, but some people may not understand. It's better everyone sees it, how it's done. There are some we are equating to x, others are equating to a constant and all that, right?
Yes.
So try to find the same question, maybe. Yeah, we can do it together. So that everyone can learn. All right. So just like before, we're going to, this time around, I'm not going to put all those, find the derivatives again. We already did that, right? We already did that. We can just go ahead and substitute those second derivatives and first derivative. The same procedure. So of x squared plus 1, remember that the second derivative is into what? Summation n equal to 2 to infinity n minus 1 an x power n minus 2 minus 4 x. The first derivative is n equal to 1 to infinity, and we're going to have n an x power n minus 1. That is the first derivative, and then plus 6 times y, and the y is simply summation n equal to 0 to infinity an equal to 0. Okay, now what's next? We simplify, just like I said before. You have first to simplify it, right? So here I'll distribute this x squared plus 1, right? So the first time I'll start with x squared. You notice that if I send x squared inside here, I have x raised power 2 and another one x raised power negative 2 plus 1, or x power minus 2. So the 2's will cancel out, as you can see. Remember the rows of indices. If you add 2 to this, you're just going to have x power n there. So we are going to end up having this. Okay, so you're going to have this first term. If you send x squared inside, the summation doesn't look good. Okay, so summation n equal to 2 to infinity n minus 1 n. This just be x power n if you send x squared inside. And then if you send 1, multiply this guy by 1, nothing will change, just be the same. So add plus. Okay, if you distribute 1, so summation, just the same expansion like algebra, right? N equal to 2 to infinity n minus 1 an x to the power n minus 2. Okay, minus, again here I'll send 4x inside. So remember that is x power 1. So if I send x power 1 here and I have x power n minus 1, 1 and negative 1 will cancel out, just leaving behind the x power n. So 4 n an x power n, and then plus plus what? The other one we send 6 inside. So I'm going to have summation n equal to 0 to infinity send 6. So 6 an x power n, and this is equal to 0. Okay, that's what we get. So what's the next thing? The next thing is simply to simplify it. Okay, so
You forgotten to add the limits for the other one.
Oh, thank you so much. I didn't put the limits here. Okay, so the limits for this is for n equal to 1 to infinity. Okay. All right. So now the next thing is to make sure that the powers of x here match, right? So what I mean here is that you need to make sure that you have x power n throughout. So the only change you're going to make is for this one here. So we do that by adding 2 to every n. Okay, we're going to add 2 to every n, or the rest is to maintain. Okay. So we have summation n equal to 2 to infinity n minus 1 n x power n plus, so I'll add 2 to every n. So if I do that, this will be n equal to 0 now, because I'm going to have n plus 2 equal to just n equal to 0, and then to infinity, this becomes n plus 2, while the other one becomes n plus 1, and then I have an plus 2 x to the power n minus the rest still the same, n equal to 1 to infinity 4n an x power n plus summation n equal to 0, okay, to infinity 6 an x power n, this is equal to 0. Okay. Now at this point, remember what you need to do. The next thing is make sure that the indexing is the same. So you compare which one is the highest, starting from the highest value of n. So the highest value of n is simply n equal to 2. So we'll make sure that we push all these other series so they start at n equal to 2. Okay, so this one will be our reference. N minus 1, n, won't touch it. And then for this one here, for it to start at n equal to 2, we need to have two terms. I need to find two terms for n equal to 0 and n equal to 1. Okay, so for n equal to 0, we're going to have 0 plus 2 is 2, 0 plus 1 just 1. So 2 times 1 over 2, 0 plus 2, just be 2a2, and then x power 0 just 1. So for n equal to 0, you have 2a2 just. And then for n equal to 1, you're going to have 1 plus 2, 3, 1 plus 1, 2, so total of 6. This will be a3, x power 1 just x. So I have 6 a3x for n equal to 1. And then meaning that the next one now start at n equal to 2. Okay, minus for this one here, it's starting at n equal to 1, so just need to find one more term, right? For n equal to 1, so the next one starts at n equal to 2. So substitute n equal to 1 here, 4 times 1. This will be a1, or this will be x power 1. So I'm going to have minus. Remember, I have to include the sign as well. 4 times 1 just be 4, a1, x. Meaning that the next one, I put still minus, right? Because, yeah, we follow the sign. Meaning the next one under that summation is n equal to 2 to infinity of 4n an x power n plus. Similarly, the last term, we need to find two more terms for n equal to 0 and n equal to 1, so that the next terms start at n equal to 2. So for n equal to 0, you notice that I'm going to have 6a0, x power 0 just be 6a0. Okay, and then for n equal to 1, we have 6a1 x, and then the next one start at n equal to 2. Summation as n equal to 2 to infinity 6an x power n, and this is equal to 0. Okay, so any question up to this far? Any question, guys?
I have a question.
Yes, please.
Yes. On the n equal to 1, we only add 1 so that it becomes 2, huh? That is why sometimes I forget.
Where?
On the first one, to make it n equal to 2, we only add 1. We don't go like 1 and then again 2.
For this one?
No, not that one. On the 4n.
On the 4n. Oh yeah, this one just take one.
The one
for n
that
equal to
has
1.
n.
Yes, just for n equal to 1. And then meaning the next one started n equal to 2. You don't have to do the 2.
Okay, thank you.
Okay, so let's move. We move. Okay, so the next thing now is to combine everything together, right? Putting all the like terms together. So the like terms, I mean the constant terms, those terms with the x alone, and those terms in the summation. So start with the constant terms. So notice that this is a constant term, and this one also is a constant term. So put those guys together, right? Okay. So 2a2 plus 6a0. That's just one term because that's a constant term. It's one term. And then plus those with x. So I have this one here, this one here, and this one here. So I have 6a3 negative 4a1 plus 6a1x. So notice that these are like terms that can be added. This one and this one are like terms can be added, which result into what? 2a1. Okay, so instead of writing all of them, I'll just write 6a3 plus 2a1x. So 6a3 plus 2a1, and then I'll put x aside because this is just a single term. Okay, plus now the next to those that are what in the summation. So summation, they are all starting at n equal to 2 to infinity. So for the first one, we get this term there, which is n minus 1 an plus the next one has a plus, right? Which is this here, n plus 2 n plus 1 n plus 2. The next one has a minus, so put a minus there, 4n an, and then the last one is what? As a plus 6an. We close this, and this x power n, and this must be equal to 0. The space, a random space there. Okay, the last is 6an. Okay, so now, since everything is equal to 0, so I have to create all these three terms. You have three terms, right? We have this constant term here, we have this term here, and we have this big term here. So I have to create everything equal to 0 because you have something equal to 0. Okay, so we have 2a2 plus 6a0. This constant term must be equal to 0. Okay, so remember that every time you have two or more terms, you solve for the term that are which one? Which is ahead of the other one, right? So a2 is ahead of a0. So we're going to make a2 the subject formula here. So if you do that, you're going to have a2 is equal to minus 3a0, right? If you divide both sides by 2. So we're going to have minus 3a0, that is a2. So you have to keep this. Okay, so I have to keep this, right? Similarly, for this term, which is just the coefficient of x, you're going to solve for a3 as well. So I'm going to have 6a3 plus 2a1. Also, it must be equal to 0. So if you solve for a3, so a3 will be equal to negative a1 over 3. If you divide it out by 6, you're going to end up having this, right? So also you have to keep this. Okay, now the next term is a term, the giant one. So the next term is that one in the summation. So I'll write a whole lot of it. N plus, sorry, it's n minus 1, an plus n plus 2, n plus 1, an plus 2, minus 4n, an plus 6an. And this must also be equal to 0, okay? Because everything there is equal to 0. All right, so at this point, remember that you have to solve for the term which is actually ahead of the rest. So I have to solve for a2. So I'll take everything to the other side of the equation. So this side I remain with n plus 2, n plus 1. So I'll take all the terms to the other side of the equation. So this will be 4n an will be positive, minus 6an negative, and also minus the other one is n minus 1, an to be negative as well. Okay, so of course this is the term an plus 2 here. Let me just I forgot that n plus 2. Let me do this. An plus 2 equal to this, right? So I'll solve for an plus 2. So an plus 2 will be equal to And if you notice an is common throughout, let me try to factorize that an. Okay. So I have 4n minus 6 minus n minus 1. An is common. And then this will be divided by n plus 2, n plus 1. And remember that we are taking the values of n from the summation, right? So the summation is starting from 2, as you can see. So the values of n are considering are n from 2 to infinity. Okay. So now what's the next thing? The next thing, guys, I think we can start substituting, but I think I can simplify this further. Let's see. You can further simplify it. So I have 4n minus 6. This will be n minus n squared plus n, right? Because if you multiply by negative plus n there, and then times an. It looks like something I can factorize, right? And then divided by n plus 2, n plus 1. Oh, so our n squared term is negative. Let me just try to factorize the negative there. I think maybe to be simple. Okay, n equal to 2. I can push negative aside. So that now I write this as n squared. This 4n plus this, that will be 5n. But since I push negative aside, that will be minus 5n. Well, this negative 6 becomes positive 6, right? Okay, I've done that just to get rid of negative in front of n squared. So that maybe I can easily factorize it. Because if you have a negative in front, maybe it may be somehow confusing to do. Okay, so is that factorizable? Is it? Hello? Is that factorizable? People, let's be responding.
Yes.
What are the factors? What are the factors?
2 and 3.
Positive or negative?
Negative.
Negative, so
Minus 2 n minus 3. So I think, oh, I forgot n here. Anyway, it doesn't make any difference because there's no term in the denominator that can cancel out with the term in the numerator. Okay. So at least, but if you write like this, comes more simplified. Okay, so we have that. Now it's high time we can start substituting the values of n. Remember that you're taking the values of n, starting from 2. Let's start for n equal to. So for n equal to 2, we're going to have a4 there. And this will be just, you notice that you have 2 here. This will be 0. Who agrees with me? 2 minus 2. 2 minus 3. This will be 2 plus 2. 2 plus 1. And this just gives you 0. Okay? This just gives you 0. And you see that all the terms coming now be zeros. Because even for n equal to 3, oh, so let me just do this. 0, a2. Because you solve this guy, right? 0, a2. And we know what was our a2 from this. Our a2 was negative 3a0, but it doesn't matter if you put that guy. This term will still die. Okay, it will still die, right? Just to go to 0 because that 2 minus 2 here. Okay. And then for n equal to 3, you notice that we're going to have f5. Even this one also die because we're going to have
it will be 0.
It will be 0 as well. Right? So we're going to have 3 minus 2. This will be 3 minus 3 now. This will be 3 plus 2. 3 plus 1. And this will be of a3, right? Because n is equal to 3. And despite us having A3 somewhere, we have A3 found, but since of 3 minus 3 there, this term also die. You notice that all the other terms now die because the next term will depend on F4. And F4 found 0. The next term will depend on F5, right? Can you see the pattern? That all the terms, the next term depend on A6. Okay? Can you see the pattern? Or maybe I show you one more. You can see it. Okay, so let me say for n equal to 4, you have A6, and this is equal to 4 minus 2, 4 minus 3, this will be 4 plus 2, 4 plus 1 of F4. But F4 we found what?
Sir,
Yes, please.
could you scroll up?
Okay, just a minute. So F4 is equal to 0, even A6 also be equal to 0. Yes, please. Where?
Just here on the general formula, the overall formula that we got. So like the minus that is outside doesn't affect what's inside.
No, if you want, you can distribute it back. It's fine, but I think this is just simple. Even if you do that, it won't have any effect. Because what is happening here, we're finding these zeros and substitute. Because if you send this guy back, you're going to have this one be what? Be negative n plus 2. Or the other one will be what? Negative n plus 3. Still, for n equal to 2, you're going to put 2 here, this will still be 0. For n equal to 3, you're going to put 3 here, this will be still 0.
Sure.
Okay? Yes. So that minus has no effect because we are just getting zeros. So notice that throughout all the terms, so all these terms up to n, whichever n, all of them will be zeros. All of them will be zeros. So the only solution we have is for those two we found, for A2 and A3. So therefore, from this, we can take a conclusion saying that our solution, therefore, our solution as y will be equal to a naught plus a1 x plus a2 x squared plus a3 x cubed plus a4 x fourth plus so on and so forth, right? Now let us substitute the values we found. We didn't find a0, so a0 should be 10. We did not solve for a1, so a1 should be there. We found a2. A2 was what? What was our a2? Our a2 was negative 3a0, while our a3 was negative a1 over 3. So okay, substitute those values. So this was negative, oh, sorry. This was negative 3a0 x squared, while the other one is negative a1 over 3 x cubed. That's all. Because the rest now, the rest of the terms, a4, a5, all of them were zeros. So you can say plus, minus, plus, dot like that. Because you don't have any more terms. All of them are zeros. So this is not an infinite series. It just ends here. Okay? This is not an infinite series. It just ends here. It doesn't go forever. Because all the terms now you're finding that are zeros. Even if you find a100, a1 million is to be a zero. Okay? So you can rewrite this by arranging a zeros if you like, by factorizing the term that have a zeros. So I have a0, this will be 1 minus 3x squared as the term for a0. And then the term for a1, this will be x minus 1 over 3 x cubed. Okay, so you can just end it there. Any question? Any question, ladies and gentlemen?
With me, I'm clear. Thank you.
All right. So someone actually, before we forget, someone sent a question on so that is like a supplementary, right? It's a supplementary question. So I'll just write a supplementary equation. On the same power series now, it's not equated equal to 0. It's equated to a variable. So I'll write this as a supplementary equation. So that we forget about it. So we have apply the power series method to solve the following ordinary differential equations. So we have y double prime minus y prime is equal to x squared. Okay, so the power series here, y double prime, remember that is a summation as n equal to 2 to infinity n minus 1 n x power n minus 2, the second derivative, right? And then minus summation n equal to 1 to infinity n x power n minus 1, and this is equal to x squared. Okay. All right, so we move. So the first thing first is to make sure that we have x power n for each. Cool. So the first one, I'll add n 2 to every n, so that we have summation n plus 2 equal to 2, just be n equal to 0 to infinity. This will be n plus 2. This one will be n plus 1. Okay, if you do that, and then this will be an plus 2, and then x power n minus summation, also add 1 to this. This also be n equal to 0 because of n plus 1 equal to 1. And then to infinity, this will be n plus 1. This will be an plus 1. X to the power n, this is equal to x squared. Okay, so at this point, you can now, since both of them are starting from n equal to 0, right? So it's okay, we don't have to change anything, right? So we can just factorize summation. So summation n equal to 0 to infinity n plus 2 n plus 1 n plus 2 minus n plus 1, okay, from the other one, an plus 1 x power n, and this is equal to x squared. Now, here is what you need to do. Since this is not equated to 0, you are equating to x squared, right? X is raised to power 2, and that is for n equal to 2. Hear me out. You are equating this to x squared. Remember that the power is n, right? The power of these guys are n values. So for only n equal to 2, you are going to equate this this term under the summation equal to the coefficient of x squared. Am I making myself clear here? Meaning the rest, you're going to equate them to 0. For only n equal to 2, you equate this guy inside the summation equal to the coefficient of x squared. What is the coefficient of x squared here is 1, isn't it? Isn't it, right? So you equate for only n equal to 2, you're going to equate this to the coefficient of x squared. It means for others, n equal to 0, n equal to 1, n equal to 3, n equal to up to infinity, they'll be equated to 0. Am I making myself clear here?
Yes.
Hello? Okay, so we just write.
Sorry, can you come again? Sorry.
We just write something. Okay. to the coefficient. Okay, I don't know if it makes sense. Okay, does it make sense?
Yes, it does.
So I'm just saying for n equal to, you're going to equate that guy to coefficient of x, which is 1. So for instance, I can bring so many, like, what if this was just a constant, let's say 5, right? So for only n equal to 0, you are going to equate this to 5. And then for n equal to 1 to infinity, you're going to equate 1 to 0 because 5 is a constant. And then if this guy was just x, for instance, it was x, then for only n equal to 1, you're equating this guy to the coefficient of x. The rest will be equal to 0. If we had another case, let's say x plus 2x squared, let's say the question comes like that, plus, let's say, 3x cubed. Who can tell me what to do here? Anyone to try? Based on what I've talked about, anyone to try? What can we do here? Let's try.
Maybe we can try to just equate when n is equal to 3. Since the 3x to the power 3 is the highest.
Okay. All right, you've tried, but since you have 3 terms here that are not equal to 0, this one is for n equal to 1 because it says for 1. This for n equal to 2, this for n equal to 3. So this means that for n equal to 1, you're going to equate this guy to the coefficient of x. Okay? For n equal to 2, you're going to equate this guy to the coefficient of x squared, which is 2. For n equal to 3, you're going to equate this guy to the coefficient of what? X cubed, which is 3. Therefore, it means that the rest, we're going to equate them equal to 0. Okay? Are we together?
Yes, we are together.
All right. So in that case, that's what we do. So if there's a constant here, let's say you add another constant, say 6, a constant. For n equal to 0, you're going to get to 6 because that one is a constant. So constant equal to a constant. Okay, so let's move. So check back to how the question was. So this is x squared. So remember that the values of n are starting from n equal to 0 up to infinity, right? So I need to be careful when I'm substituting n equal to 2. I need to equate to the coefficient of x squared, just like I said. Okay, so for the first one, remember we're starting from n equal to 0. So let's solve this guy for n. So n plus 2. Oh, we make the change in the subject for me, right? So n plus 1, an plus 2, minus n plus 1, an plus 1. This is equal to 0 for n equal to 0, n equal to 1, n equal to 3. Okay, take note of that, not 2. N equal to 4, and so on and so forth. And this guy, okay, we can solve for n plus 2, right? Let's solve for n plus 2. So an plus 2 will be equal to what? N plus 1 times an plus 1 divided by what? N plus 2, n plus 1. Right? So n plus 1 and n plus 1, as you can see, cancel out. What you end up having just be an plus 1 over n plus 2. So we're only doing this for the values of n equal to 0, 1, 3, 4, 5. And it will be equal to 1. Let me write it again. So n plus 2, n plus 1, the same thing. An plus 2 minus n plus 1, an plus 1. It will be equal to 1 for only n equal to 2. You are equating to 1, okay? So that your an plus 2, so this will just be a special case itself, to be equal to 1 plus n plus 1, an plus 1, everything divided by n plus 2, n plus 1. I'm emphasizing this for only n equal to 2. Okay, so now let's start. So let's start. So for that equation, an plus 2 is equal to an plus 1 over n plus 2. Let's start substituting the values of n. So for n equal to 0, we have a2, and this is equal to what? a1, because we're going to have a0 plus 1, that's a1 divided by 2, okay? And then for n equal to 1, we're going to have what? a3, and this is equal to a2 divided by 3. And we only found a2 from the previous, right? a2 is simply a1 over 2. So you can make that substitution. So this will be a1 over 6, right? If you do that. And then for n equal to 2, be careful here. Don't forget. For n equal to 2, we have to get the other one, right? Remember we said for n equal to 2, we're going to use this, right? Isn't it? So we said. So for n equal to 2, we're going to use that. So an plus 2, this is equal to 1 plus n plus 1, an plus 1 over n plus 2, n plus 1. So this will be a4 equal to 1 plus, this will be 2 plus 1 is 3, a3. And then divide by what? Divide by 2, that is 4, 3, that is 12, right? Okay, divide by 12. But you know that a3 is what? a1 over 6. So we can substitute that. We're going to have 1 plus 3, a1 over 6, divided by 12. So our a4 will be equal to 1 plus a1 over 2, okay, by dividing 3 into 6 2 times, right? And then over 12. So what I'll do, I'll multiply both on top and down by 2. I don't want to have the fraction there. So this will be 2 plus 2 and 2 there will cancel, just have a1. Okay, divided by 24. So that is our a4. And then for n equal to 3. So for n equal to 3, you have a5, and you go back to the other one, where you're equating to 0. So you are using this equation here for n equal to 3 now. So that will be a4 over 3 plus 2, which is just 5. So a4 over 5. Okay, so similarly, in place of a4, we're going to put what? We just found a4, which is that. So 2 plus A1. Okay. Over what is 24 by 5? That is 120. Okay. Are we together? So can end here, can get more for n equal to 4 and all that, right? And so on and so forth. So you can say therefore y is equal to A0 plus A1 plus A1x plus A2x squared plus A3 x cubed plus A4 x power 4 plus A5 x power 5 plus so many terms coming. So y is equal to A0. We didn't find any A0. Did we? No. Plus, we didn't find A1. I doubt we found A1 here anywhere. Did we? Started from A2, right? Yeah. So A1 didn't find A1, so maintaining the way it is. But we found A2. Our A2 was A1 over 2. X squared. Our A3 was A1 over 6. Okay, A1 over 6. X to the power 3. Our A4 was, I remember very well, it was 2 plus A1 over 24. And then this x power 4. Our A5 is 2 plus A1 over 120. X to the power 5 plus so on and so forth. Okay, so that is what we get as our solution. Anyone with a question who's not clear? Anyone who's not clear? Pick up. Otherwise, you ask me exam.
It's clear, Mr. Mete.
If you're not asking now, you ask it next week. It's my exam. Huh? That's what I want to ask it next week. It'll be too late.
So
Not so.
sometimes, Mr. Mete, when we are going through, it's okay. But when you sit down on your own, you start going through. That's why you see, oh, I didn't get that. I didn't get. That's why we keep on asking. Don't get fed up with us, please.
Okay. All right. So we continue. So I'm sure you're all clear on if it is your differential equation is not equal to 0 now, how you handle it. Okay. All right. So let's finish question 1, of course. So question 1, there's that part which says show that blah 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 there. Okay, back to question 1. So part C of your exam. So it says that show that given y is equal to a summation. Just I think write the whole equation. So the question show that y is equal to the summation, okay, as m moves from 0 to infinity of 2 to the power m x to the power m divided by m factorial is equal to, okay, if you have to expand this, it's that, right? 1 plus 2x plus 2x squared So that's the expansion of that series, 4x cubed over 3. Okay, so I have to show that is that one is a solution. Is a solution to the differential equation. Differential equation. So the differential equation given is y prime minus 2y equal to 0. So I have to show that if we substitute this in our differential equation, we get a 0. That's the meaning of that, right? Okay, so let's first find the first derivative of this, because in our differential equation of the derivative, right? So I have to get the first derivative of that. So we have our solution. Y is equal to, the battery is very low. Let me just plug in the power patch. Okay. Okay. No, the quiz is postponed to next to Thursday. Finala. It's Thursday.
Okay.
All right. Okay, so we have y is equal to the summation. Okay, summation m equal to 0 to infinity 2 to the power m x to the power m divided by m factorial. Okay. So now let's get the first derivative for this. So what is our first derivative? So our first derivative as y prime will be equal to the summation. Remember that our variable we're interested in is x. So this will be m equal to 1. So we're differentiating this with respect to x, not with respect to other letters. Okay, so this will be what? You drop m, of course, this will be 2 to the power m. You've dropped m here, right? Times m, and then x to the power m minus 1, right? And then divide by what? Divide by m factorial. Now get this information and plug it in our differential equation given. It must give us to 0 if we do that. Okay, so let's plug in that. So our first derivative is summation m equal to 1 to infinity, okay, 2 to the power m times m, so right times m, so that it is clear, and then x to the power m minus 1 divided by m factorial minus 2 times y. What is y? Y is what we are given, right? Summation m equal to 0 to infinity 2 to the power m x to the power m divided by m factorial, and this should give us 0. So as it is here, you can see that it doesn't make sense. How can it give us 0? How can we subtract those two? Okay, let's do a further simplification here. Let's see what we can do. Okay, so remember that this one is x power m. This is m equal to 0 and this x power m, right? Oh, this one is x power m minus 1. We have to change it, eh? Okay, we have to change that like we have been treating others. So instead of it starting at m, instead of it being x power m, should be x power m minus 1, so it should be x power m just. So we're going to do that by adding m, by adding 1 to every m. So this will be summation. This will be m plus 1 equal to 1. This just will be m equal to 0. If we add 1 to every m to infinity, this will be 2 to the power m plus 1. Or the other one will be m plus 1. And then this will be just x power m. And then this one will be m plus 1 factorial. So remember that I'm adding 1 to every m. Minus, I'll send this 2 inside. Okay, I'll send that 2 inside. M equal to 0 to infinity. Now, since this 2 is sent inside, you have another 2 raised to power something. So remember that you have the same bases, so just add the powers, right? So this will be 2 to the power m plus 1, because this 2 outside is s power 1. So the powers just add up. So go down 2m to the power 1 plus 1. Okay, and then x m over m factorial. And this must be equal to 0. Now, at least, but for now, not yet, right? We haven't reached there where those guys get cast out, isn't it? Because yes, we have 2m plus 1, we have 2m plus 1, no, those guys are matching. We have the same summation, x power m, but the only problem we have is what? M plus 1 on top here, and m plus 1 factorial down here. That's one problem we have. Okay, so that these guys can look the same, because we want to make these guys to be equal. So that they give us a 0 and subtract them, right? So what I'm going to do here, I'm going to remind you one thing. Remember, recall, okay? If you have n factorial, how do you expand these guys? Do you remember that expansion of factorial? Who can tell me the expansion of factorial? Hey, let's respond. Who can tell me the expansion of factorial? Who remembers? Okay, so the expansion of factorial just be n itself, and then you start reducing it, right? N minus 1, n minus 2, n minus 3, n minus 4, up to just like that. So when you stop it, don't forget to put factorial stop, right? Because it shows that it continues, right? So where I stop, you're going to put a factorial there. Okay. All right. So I'll give an example. Let's say I want to expand 20. You have 20 factorial. Eh? So 20 factorial can be written as what? 20 times 20 times minus 1. So be 20 minus 1, just be 19. Times 18. Times 17, so on and so forth. So if you want to stop here, don't forget we're going to stop, put a factorial if you want to stop there. Because it shows that you are still expanding. Okay. So 20 times 19 times 18 times 17 factorial. Because this, we can still reduce it up to 1. Okay. So we can use the same knowledge here. Okay, because we have some factorials there. We have to simplify it something. So let's try to use this concept here. So with the concept we have here, you know what? We have to make these guys to be the same, isn't it? So we have m plus 1 on top, which is making everything complicated. And we also have m plus 1 factorial here. So let's try to simplify that. So I'll simplify that by expanding the factorial in the denominator here. So if I expand that, let me see. So if I have m, my m plus 1 factorial here, what does it become? So okay, tell me the first one is the same itself. Okay, to be m plus 1, of course. That will be the first term. Times the second term should be m plus 1 minus 1, isn't it? The third term just like that. Now I want to go further because what I wanted is having this m plus 1 in the denominator so that it can cancel out this m plus 1 on top there. I don't have to continue going further. I can just end it here. Okay. Because I want to find a way of getting rid of this m plus 1 here. And also getting rid of what? M plus 1 factorial. So that I can just have m factorial. This guy should be the same. So I'll expand it up to that level. So this same as what? m plus 1, m plus 1 minus 1, that's just m, so m factorial. You notice that now, instead of me writing m plus 1 factorial, I can add this as what? M plus 1 times m factorial. So if I put that in the denominator, m plus 1 and m plus 1 comes out, I'll just leave behind m factorial. Okay? So for that reason, let's do this. Okay? So I have that summation m equal to 0 to infinity 2 to the power m plus 1 okay, 2 to the power m plus 1. All right. And then times m plus 1. Okay, times m plus 1. Okay, x to the power m divided by, that is m plus 1. We found that, and times m factorial if you expand that. So it's equal as m plus 1 times m factorial. And then minus the summation m equal to 0 to infinity 2 to the power m plus 1 x to the power m divided by m factorial, and this should equal to 0. And from this, you can notice that this m plus 1 now and this m plus 1 will cancel out, just leaving behind summation m equal to 0 to infinity. This is just 2 to the power m plus 1 x to the power m divided by m factorial, minus also the same thing, m equal to 0 to infinity 2 to the power m plus 1. Oh no,